In this video, we're going to look at another example of box and whisker and standard deviation. And so what we've got here is we've got two classes whose max mark could have been 60. Comment on the skewedness of the results of class X. So you can see that the biggest box in class X is on the right hand side. So you'd say skewed to the right or positively skewed, whichever you want to say. In which class is a standard deviation of the marks bigger? It would be in class X. Why is that? Because the box is bigger. In general, both boxes are bigger, which means there's more variety. There's a greater standard deviation away from the middle. Comment on the average performance in the test of the two classes. Use relevant statistics to support your answer. I would say that the average performance was the same because they both have the same median mark, although higher marks were achieved by class X. That would be my comment on that for 2 marks. Then this is a really nice little mixed up question of box and whisker, mean, standard deviation. And so let's check this guy out. The time in minutes that it took for the first goal to be scored in 7 football games was recorded. The times in ascending order are represented by A, B, C, D, E, F, G in the table below, and the following observations were made. All the goals scored were at different times, so there's not going to be any duplicate number here. The minimum time for the goal was 5, so we know that A is 5. The range was 48, so that means highest minus lowest would be 48, so G would have to be 53. The median time, which is bang in the middle, which is D, was 22, so D is 22. The difference between the time of the lower quartile and the minimum value was 7. So between these two, the gap was 7. So that would put B at 12. The interquartile range was 28. So that means F minus B, the upper quartile, minus the lower quartile, would be 28. But we know that B is 12. That means that if I take it across, F is 40. The mean time was 27, so if we add up all of these, it will be 27. So what you can do so far is you can say that the total will be 27 times the 7 data that you have, and that gives you your answer of 189. So just keep that in the back of your mind. And then E equals 2C. So E is 2C. And so if I add up all the data, the 5, the 12, the 22, the 40, and the 53, and the C and 2C, because E is 2C, then I'll get my answer of C plus the 2C plus all the numbers added together should get me my grand total, which was an average of 27 times the 7 data. That leaves you with 3C equals 57. So C would be 19 and E is just 2C. It's just double that, so it's 38. And there you've got all your letters. If the standard deviation for the data was 15,87 minutes, how many goals were scored within one standard deviation? And so you know from earlier that your mean was 27, so that's your mean. And then to work out how many fall within one standard deviation, you want to add your standard deviation and minus your standard deviation, and that will give you your legit interval. And so your legit interval will be somewhere between 11.13 and 42.87. And so we'll look in the data to see how many numbers fall between that. So the 12 is good, C was 19, E was 38. 19 is somewhere between there, 22 is somewhere between there, 38, 40, 53 is outside of here, as is the 5. And so it was just those 5 data. So 5 goals were scored within one standard deviation of the mean. I hope that you found that example helpful. If you did, please like this video, subscribe to our channel, and share it with your friends. Thanks.